All right, guys, our last lesson of chapter 7 is going to be section 7.5, which is proportions and triangles. The last couple lessons we've been focusing on triangles and the specific proportions we see within them, whether it's our shortcuts such as AA, SAS, or SSS, or if it's right triangles with our geometric means. Today we're going to be talking about some special cases with our proportions. Today will be an easy lesson, which will be a nice change from our previous lesson. Please feel free to stop to write things down. Please pause the video if you need to do that, or to rewind if you need me to repeat a concept. So we're going to start off with some theorems. We got 3 theorems to talk about. First is theorem 7.4. which is called the side splitter theorem. Now think about that name, side splitter. We are going to split the sides of a triangle as shown here. Now this might look familiar. It kind of looks like mid-segment because it's parallel to the bottom. But it's not exactly mid-segment, but it is similar. If a line is parallel to one side of a triangle and intersects the other 2 sides, then it divides those sides proportionally. So with mid-segment, we learned that if we cut these in half, then we ended up having parallel sides. That's what's happening here. But what is different is that this happens whether I cut it in half or in a different way. If the line is parallel to a side, then the entire side is proportional to the other triangle. So, because this is parallel to this, then XR and YS are proportional, RQ and QS are proportional, as well as QR and the entire side QX, QS and the entire side QY, as long as these are parallel. When these are parallel, it cuts the sides of this triangle perfectly so that everything is similar. Just make sure that you match the corresponding sides. If I'm only going to do this segment here, I need to do only that segment over there. Our next corollary, and this is a corollary to the side splitter, is if 3 parallel lines cross 2 transversals, then the segments on the transversals are proportional. We saw something similar to this where if they were equidistant apart, then they were always equidistant apart. But what if they're not equidistant apart? Then they're still similar. Because these lines are parallel, then every distance on this side is proportional to every distance on this side. So AB over WX would equally compare to BC over XY. Those proportions are the same. Our last theorem is the triangle angle bisector theorem. If a ray bisects an angle of a triangle, then it divides the opposite side into 2 segments that are proportional to the other 2 sides of the triangle. Meaning, if I bisect an angle, then you end up having these 2 sides. Now these 2 sides are not equal, but they are proportional to the sides of the triangle that were not cut. So CD over BD is equal to CA over AB. All of this ends up being proportional. These 2 triangles end up being similar. So all of these are utilizing previous theorems we have talked about by either bisecting an angle or cutting the sides up. We're going to talk about how to build those proportions now. Starting off with the question 1, find the missing variable. So on both of these questions, this is the side splitter theorem, so this is theorem 7.4. All right, theorem 7.4 is using this to go ahead and solve for x. Now what we have to do, our big thing here, is to write our proportions by matching the corresponding sides. So start off with problem A. If I start off with y, what does y correspond to on this picture? Well, it's going to correspond to 6. Okay, the other length on this side is 12. What will 12 correspond to? 10. So y over 6 is equal to 12 over 10. Because these 2 lines are parallel, this top side here is proportional to the bottom side here. So now take a look at your proportion. You can definitely solve that using cross products. Cross multiply 10y equals I believe that's 72. Yep. Solve for y by dividing both sides by 10. Y equals 7.2. Okay, now this one looks a little bit more complicated because I got expressions here, but we've practiced with that before. So what I want you to do first is to attempt to just set up the proportion on your own. Okay, go ahead and just write the numbers in the right spot of your proportion. Pause the video now. All right, hopefully you guys got these in the right spots. You should have 9 comparing to 12 and 4x minus 2 comparing to 3x plus 2. Now you might have these reversed, like upside down on both sides, or flip-flopped on both sides. That is fine. Just make sure that you have them comparing to the right things. From here, I'm going to cross multiply. Now make sure you cross multiply this correctly. 9 times 3x plus 2 will give me 27x plus 18. 12 times 4x minus 2 will give me 48x minus 24. So this is my equation. From here, I'm going to combine my like terms by minusing 27x on both sides. 18 equals 21x minus 24. Add 24 to both sides. 42 equals 21x. Divide both sides by 21. 2 equals x. This part is nothing new from what we've been doing. What's new is really just the setup, recognizing that because these are parallel, these match up, set up your proportion. Now, I want you to go ahead and try problem 2 on your own before I go over the answer. Okay, so I'm going to have you guys try it on your own. Please pause the video and try the question now. All right, hopefully you guys tried that question before you're looking at the answers. You should see that x would compare to 70 and 62 would compare to 56, giving you this proportion. Cross multiply, you're going to get 56x equals 4,340. Then you can divide by 56. X equals 77.5 feet. And there's your answer. Okay, same concept as question 1, except we don't have a triangle. We have parallel lines, but still this is side splitting. We are splitting this side with parallel lines, which means that they're proportional. These are proportional. All right, last question, guys, and this is our angle bisector theorem. Here's the angle bisector. We have 4 lengths. We have to set up a proportion relating the correct items. Okay, so if I start off with relating the bottom, 9 should compare to the other bottom, 15. But what is that other proportion? Well, 9 is on the left side, so I'm going to choose the side that is also left, x, which compares to the other value, 25. Cross multiply, 15x will equal 225. I'm going to divide by 15. X equals 15, because 225 divided by 15 is 15. All right, guys. So we went through that lesson really quickly, 9 minutes. So please go ahead and please go back to rewind, rewatch any of those if you need help. Go ahead and get started on your section 7.5 homework. Make sure that you're showing all work on those questions. All right, thank you guys. Bye.